So 61, and this is section 10.4, number 61, says to verify the identity, and then they give me tangent of 2 theta equals, and it says 1 over 1 minus tangent theta minus 1 over 1 plus tangent theta. That's the identity they want me to work on. And I always tell you guys, start with the side that's more complicated, right? Which side do you think I'm going to be starting with? The right side. Now that'll only work if we know something about the left side, okay? Page 784. Sorry, Nicole. 784. So I want to go ahead and work on the right-hand side. Hey, can I subtract these fractions? Not unless I get a common. Yeah. Now, let me go back to this, guys. If I do 1/3 minus 1/7, how do you do that? What's the common denominator? How'd you get it? Well, yeah. I mean, you can just multiply, right? You could always go for the least common denominator, but one easy way to get a common denominator is just multiply them, right? So I claim that I can work on the right-hand side. I can write 1 over 1 minus tangent theta, but what I'm going to do now is I want to multiply by 1 plus tangent theta over 1 plus tangent theta so that I'll be able to have a common denominator. You see that? What do you think I'm going to multiply the second fraction by? It was 1 over 1 plus tangent theta. But what am I going to multiply it by?
1 minus tangent theta.
That's right. 1 minus tangent theta over 1 minus tangent theta. It's funny. It's exactly like you would do here. How do you change these to 21? You multiply this one by 7 over 7, and you multiply this one by 3 over 3. It's the same process. It's just that it's got these ugly trig expressions that are brand new to us, and so sometimes that slows us down. All right, but I'm going to go ahead and work on this now. And eventually, I'd love to get it to equal the left-hand side, tangent of 2 theta. All right, we'll see what happens. In the numerator here, I just have 1 plus tangent of theta. In the denominator, by the way, is there another way to write this? 1 minus tangent times 1 plus tangent. Well, you can multiply it out, right? But if you multiply it out, what do you get?
1 minus tangent squared theta.
Well, yeah, I mean, let me show you how we got that. You're right. That's it. Let me do it slowly in the other fraction. Because you get 1, right? You're doing first, outer, inner, last. You get minus tangent theta, but then what's the very next thing you get?
Plus tangent theta.
Plus tangent theta, and then you get minus tangent squared theta. So do you guys see how that works? Your denominator, you get rid of these, you just get 1 minus tangent squared theta. And up here, I guess, what's 1 times 1 minus tangent? It's 1 minus tangent theta. So now can I subtract the fractions? Sure. By the way, over here, let me go back to the problem that's almost off the screen. How do you do this? What do you get? 7 21sts minus 3 21sts? 4 over what? Okay, that's important. The denominator is going to stay the same. So let's keep the denominator as 1 minus tangent squared theta. That's the denominator. Now what about the numerator? Well, this may be a little tricky. I have 1 plus tangent theta, and then I have minus 1, and then what do I have?
Plus tangent.
Do you guys see how that's plus tangent? Because you have to distribute the negative. Okay, so what do we get in the numerator? 2 tangent theta, because tangent theta plus tangent theta is like x plus x is 2x. Tangent theta plus tangent theta is 2 tangent. What happened to the 1s? They're gone. All over what? 1 minus tangent squared theta. And I don't know if you've seen this enough to know what that is. But you go ahead and look at the gray box in this section and you'll see, oh, that's the tangent of 2 theta. That's exactly the identity for tangent of 2 theta. It's the same formula you'll find in a box in that section. Okay? I have time for hints on one more if you want, and then we're done. Which one? 63? Oh, very next problem. Holy mackerel. That looks hard. All right, well, we'll try. Well, I hope I can get 63. I can tell you right off the bat, I may need a different identity that we haven't gone over. That might be a bad one to assign you guys. Sorry about that. 8 sine 4th theta is equal to, it says, the cosine of 4 theta minus 4 times the cosine of 2 theta plus 3. Wow. I mean, there's certain things that come to mind here, okay, for me. When I see cosine of 2 theta, do you guys know what that equals? Wasn't there a song? Because this is theta plus theta, right? Sine, cosine, cosine, sine, and then?
Cosine, cosine, sine, sine.
Cosine, cosine, sine, sine. How many remember that song? Okay. What does that have to do with this? Well, it's cosine, cosine, but it's theta and theta, so it's cosine squared theta, right? Minus sine squared theta. Thank you. How many are with me so far on this? Okay. And I also claim that this cosine squared, that can be rewritten as 1 minus sine squared theta. Matter of fact, wasn't this problem 93? You had to show how this worked. So now I have that the cosine of 2 theta is 1 minus 2 sine squared theta. I think to start this problem, I have to put that in here. And I can't finish it in 1 minute, but I will tell you that my next move would be to take this guy and try and write it maybe as the cosine of 2 theta plus 2 theta. And if I keep working it out enough, I think you're going to get the right answer. That's all we got for today, guys. I'll show it to you next week if you like.
Can you keep that up for a second?
Yeah.